is Mrs. Duffy, and today we're going to take the forces and motions unit test. First, we'll do the vocabulary section. For the first section, our vocabulary words are force, inertia, net force, Newton's first law, Newton's second law, and Newton's third law. So our first word is a push or pull. So you just kind of have to look. You can write down A, B, C, D, E, or F. Which one means to push or pull? Next is the tendency of all objects to resist in motion. Next is an object at rest stays at rest and an object in motion stays in motion at the same speed or direction unless it experiences an unbalanced force. The law of inertia. Next one is the combination of all forces acting on an object. Next one is whenever one object exerts a force, the second object exerts an equal and opposite force on the first. And last one, the acceleration of an object depends on the mass of an object and the amount of force applied, or force equals mass times acceleration. Next section of vocabulary words. Our words are speed, acceleration, velocity, motion, reference point, and position. So our definitions. The first one is a location to which you compare other locations. So which word from the word bank is a location to which you compare other locations? Next is speed in a certain direction. Next, a measure of how far something moves in a certain amount of time. A change in position over time. Describes the location of an object. And the rate at which the velocity changes. Next section is for speed and distance. So I gave you the formula for speed. Speed equals distance over time. So you're going to use this formula to solve the next few questions. Number 1, a man rides a bike for 1.5 hours and goes 27 miles. What was his speed? A, 27 miles an hour, B, 18 miles per hour, or C, 90 miles per hour. Number 2, Catherine and Bridget decide to get a hot chocolate at Starbucks after school. They travel the 2 miles in 0.75 hours. What speed did they walk at? A, 1.5 miles per hour, B, 2.67 miles per hour, or C, 3 miles per hour. Next, we're going to use the formula to find the distance. So distance equals speed times time. Number 3, Caitlin and Corey decide to walk to the local ice skating rink. They travel at a speed of 3.5 miles per hour, and it takes them half an hour to get there. How far away was the ice skating rink? A, 1.75 miles, B, 7 miles, C, 0.12 miles. Number 4, what unit is used to measure distance? Is it A, meters per second, B, meters per second, or C, meters? Number 5, the graph below shows the distance a car traveled in 5 seconds while moving on a freeway. What was the car's average speed? So you kind of have to look at this graph and figure out, use the speed formula, distance over time equals speed. So what was the speed if we do distance over time? 0 meters per second, 14 meters per second, or 28 meters per second. Number 6, 3 runners compete in a race. Before the race begins, 2 runners are at the starting line and another is 10 meters away. What term best describes the starting line? Is the starting line relative motion, a reference point, or change in position? Number 7. Which sentence best describes the runner whose distance time graph is shown below? A. The runner ran forward for 2 seconds, then he ran backwards for 2 more seconds. B. The runner ran forward for 2 seconds, then he ran forward more slowly for 2 seconds. C. The runner ran forward for 2 seconds, then he turned right and continued forward at the same speed for 2 more seconds. So when you look at this graph, what does it say? A, B, or C? Number 8 and 9 are kind of together. So a student allowed 4 different objects to roll down a ramp. He measured the distance at each object rolled and the time until each object came to a stop. He plotted each point and connected it with the line from the origin of the graph. So which object had the greatest average speed? So I want you to figure out the speed. So remember, speed equals distance over time for each of these objects. And then tell me which had the greatest average speed. Go ahead and pause if you're not ready. But the next section is on acceleration. Use the formula to find the acceleration. You have the final velocity minus the initial velocity over time. Number 10. A gingerbread man is in a race. He crosses the finish line at a speed of 8.7 meters per second and slows to a walking speed of 2.2 meters per second in 10 seconds. What was his acceleration? So this one you have to use the formula to figure it out. Number 11. How do you find the average acceleration of an object? A. Divide its distance by the time it took to travel that distance. B. Subtract the final position from the initial position and multiply by change in time. C. Subtract the initial velocity from the final velocity and then divide by the change in time. Number 12. A penguin is standing on an iceberg when suddenly a killer whale surfaces nearby. The penguin quickly reaches a speed of 4.3 meters per second in 2 seconds. What was the penguin's acceleration? A. 2.15 meters per second squared. B. Negative 2.15 meters per second squared. Or C. 8.6 meters per second squared. Number 13. Rachel conducted an experiment with a radio-controlled toy car. The sketches show her findings. What is the average acceleration of the car? A. 5 meters per second. B. 10 meters per second squared. Or C. 20 meters per second squared. So use the information here, plug it into the acceleration formula, and find out the average acceleration of the car. All right, next section is force. Number 14. If you push 4 objects with equal force, oops, that should say 3, but if you push all objects with equal force, which would go for the furthest? A. Football, B. Bowling ball, or C. Tennis ball? Number 15. Take a look at the free body diagram and calculate the net force and write it here. Number 16, same thing. Look at the diagram, calculate the net force, and circle it. Number 17, a moving object hits an object that isn't moving. Which of the following statements is true according to Newton's third law of motion? A, each object exerts a force on the other, and the two forces are equal and in opposite directions. B, each object exerts a force on the other, and the two forces are equal and in the same direction. Or C, a moving object exerts a force on a stationary object, but the stationary object does not exert a force on the moving object. Number 18, Anthony was sledding down a hill. Unfortunately, when he got to the bottom, he crashed into a snowman. If the action force is that Anthony put a force onto the snowman, according to Newton's law, what is the reaction force? A, the snowman falls over, B, Anthony falls off his sled, or C, the snowman puts an equal force back on Anthony. And number 19. What would happen if you applied a force of 20 newtons on an object that has a net force of 0 newtons? A, the object would not move, B, the object would begin moving, or C, the object would move at a constant speed. All right, go back, check your work. Nice job.